Yeah.
Hi everyone. So I'm going to be taking you through a quick intro to this session, and this session is going to be looking at data quality assurance processes in R. And thanks to Irene, Upendo, Jack, and Kevin, who assisted with organizing this presentation. So in the demo, we're going to be covering 6 dimensions of data quality, and that is timeliness, completeness, uniqueness, consistency, validity, and accuracy. Assessing data that data is complete, whether data is complete, unique, timely, consistent, valid, and accurate should be a prerequisite for any analysis. If your data is bad, there's no methods or methodology that can assist with to make it right, and therefore that's very essential. That's why it's very essential to ensure that the data is done in a very consistent and accurate way. And that data happens for so many reasons, and some of these reasons ranges from bugs in the database, manual entry, data integration, loss of expertise, etc. That's why it's important that any user of data needs to be equipped with the tools and techniques to detect, resolve, and communicate these issues. Data users are encouraged to use their technical expertise and domain knowledge to detect inconsistency and make sure that the analyses are based on reliable sources that pass quality control measures. In this demo, we're going to be reviewing 6 dimensions of data quality and go through tools and techniques that can be used to deal with this with quality issues when they arise. For example of some of the data quality issues, here I'm showing you an example of a table, a small table that we made. So that when you look at the 4th column, you can see that some columns have information that are talking about the same thing but are not captured in a similar way. Some are captured differently, and that when you try to do analysis, that can be analyzed as different information. Therefore, it's very essential to make sure that things are usually captured in a uniform way. For example, South Africa is in the 4th column is like on one row is spelled as South Africa in full, and the 2nd column, yes, Mario, can you hear me?
Yes, I think your microphone, the audio is very, very bad. A headset or maybe just decrease the sound of the mic or something, because the audio is not, it doesn't make for easy listening.
Now try now.
Can you hear me?
Yeah, that's much better.
Is this better?
Yeah.
Okay. So as you can see in the 4th column, some information are captured in small letters, and others are captured in capital letters. Others are using abbreviations, and so that's usually is prevented. Like can be prevented before even you start capturing. One of the ways you can avoid that is like creating something like as a drop down in your database that consists of a list of names that you can choose from. So that's one way you can fix that issue. And then you can see, then on the other column, you can sometimes information might be missing. That would consist as incomplete data. Like for example, in the 3rd column, you can see that there are some not applicable information that should in most parts be you try to get as much information as possible. So sometimes you have missingness in the data, and that's one area of like missingness. And then another problem with this data set, you can look at column row 4 and row 5. row 5 and row 6 consist of similar information. That way, you can see that that data is not unique, it's actually a duplicate. So that should also be avoided in one way. One way you can avoid that. I'm sorry, can someone mute their microphone? Okay. Window, can you please mute your microphone? Okay. So someone has a microphone open. It's fine. We're almost there. So that is an example of like duplicates, and duplicates can be avoided to make sure, like, and also at the beginning of data entry, where you make sure that no data can be that each study ID can only be entered once. So those are the validation checks you can add on things like RedCap when you are designing your database. So, however, once these errors have happened and you've exported your data and you're noticing this data, there are things you can do to assess that data quality. One of them is using like tools like R. So like one of them is using tools like R. R is a language for data analysis. And can help detect these inconsistent and make sure that analyses are based on reliable data sets. R is a free software environment for statistical computing and graphics. It compiles and runs on a wide variety of Unix platform, Windows, and Mac. And it has also an interface called RStudio that you can download. So R is a case sensitive. Commands are usually separated by a semicolon or by a new line. Comments can be put anywhere starting with a hash mark. Everything at the end of this line everything is on this line is a comment, and it's usually labeled like in green. So, then you can assign a value to an object using an arrow or an equal sign. Some of the places you can find helpful online resources for R will be CRAN, where you download the R compiler. You can also download RStudio using that link, www.rstudio.com. You can download RStudio Cloud using rstudio.cloud, and then you can get like useful resources at these links that contain manuals and useful information that can guide you through R. So in this session, Jack is going to be showing you a demo on how you can clean or detect these issues using R. And so I'm just going to pass the mic to Jack.
Thanks, Arthemon. Okay. 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 Can you hear me? Can you hear me? All right. Thanks, Arthemon, for the presentation, and thank you so much to Upendo and Irene as well. This was sort of a collaborative thing. We're just reporting on what we all do. Okay, I'm not sure how much time I have. Daniel, how much time do I have?
$20 minutes more, Jack.
20 minutes more.
Yes.
Okay, perfect. You can all hear me, right? Okay, so I kind of wanted to do this. I kind of wanted to do this as an interactive thing. So everyone with a computer who feels like they might be doing this sometime in the future, maybe if you'd like to follow along, that would be great. All right, so the way we're going to do this is we're going to log into something called RStudio Cloud. To do that, you need the internet connection. I'm kind of hoping that everyone on this call has good enough internet for this. So if you feel like you are going to be doing any data analysis in the future, please follow along and then put comments in the chat box if you're having issues with anything that I'm doing. I'll try and go slow. Okay, so if you can see now my screen, the first thing I'm going to do is open my browser. I'm going to do this in Firefox. Any browser is fine. And what I'm going to do in the top is I'm going to type into Google RStudio Cloud. Can I get a quick roll call on the chat? Is anyone actually doing this along with me? If you're going to do this, if you're doing this along with me, maybe just give me a shout in the chat so we can see who's going to get involved.
Yeah, I'm doing it.
You don't need to install anything. It's literally just on the internet. Oh, Evans, perfect. Thanks, Evans. Okay, cool. Anyone else? Right. I'll try and speak loud. Please let me know if you can't hear me. I've been having problems with my mic all morning. Okay. Mike, I have a local R installation. Okay, cool. Yeah. Isaac also perfect. I think Mike, maybe try the Ask Cloud version for now. It might be quicker because I don't know how long it'll take the other way and you might miss some stuff. All right, so I've Googled RStudio Cloud. You can see that, right? Cool, thanks, Mike. Okay, so I'm gonna click on this top link and then I'm gonna log in. You should be able to do this with your Gmail account. So like I'm gonna just log in with Google. Ruben, you're also there. I'm gonna click on this login with Google button there. And then I'm gonna choose my Gmail account. And this is gonna take me to the welcome page here. So I'm just gonna give everyone about 2 minutes to get to this point. And then please let me know in the chat when you get there. Oh, I'm just gonna close that top thing that's up there. All right, so please everyone let me know when you log in and you see your workspace in our cloud. I'll give you guys a few minutes. I think the best option is the Gmail one. That should be quite quick. Okay. Takuto is in. Evans is in. All right. Excellent. All right. So the first thing we're going to do is go to the top corner. Perfect. Oh, I could tell that. Okay. The top corner here and click on this new project button. Do you see it? Everyone sees it. And then you're going to scroll down to new project from Git repository. Do you see that there? I'm going to click that button and it takes me to this thing. So the next thing I'm going to do is open a new tab and we're going to search for SickleInAfrica GitHub. All right, so the top link there, can you see it? Or maybe the bottom one, let's go for the bottom one. The one just below it. This link there, can you all see it? This is like on the side an advert for our SickleInAfrica GitHub page. So if you click that link, it should take you there. Is everybody there? All right. Okay, yes, Evans is there. Okay, so we're going to scroll down. There's lots of stuff here which should be helpful for the consortium in terms of data analysis stuff. Oh, yeah, you're not there. Okay.
Yes, what is the name of the project?
Hello?
What is the name of the...
Oh, okay. So what we did, we got into RStudio.
On the new browser. I'm here.
Hello, I hear someone talking. Hello? Thanks, Mike, for putting that in the chat. Perfect.
Okay.
Okay, so we're here now, right? So Mike has put a link in the chat for the GitHub account. Thank you, Mike. So you're going to scroll down and you're going to see the top link there. It says Sickle in Africa database workshop. Do you all see it? All right. Okay, so I'm going to click there and that takes me here. Can we see?
These are the things you're supposed to be working with.
Kutala, you still lost? All right. Ah, perfect. Okay, cool. So you see this green button in the corner that says code. My mouse is moving around in there. Can you see? Ah. So you're going to click that button and then you see there's a little copy sign here. I'm going to copy the URL and I'm going to post it in the chat there as well so you can all see it. When I copy that link and then you want to go back to RStudio Cloud on the other side. So everyone's copied that link, right? You want to go back here and then you want to paste it into that box. Have we got it? How are we doing? Everyone there? So you can either paste it from GitHub or you can copy the link that I've just posted in the chat into here. Ooh. Yeah, you okay? I see some people having problems. Okay. If you want to talk, you can talk. Feel free to just unmute yourself and talk.
Can you go back until when you opened the new browser and how you took there, what you took there?
Yeah, should I do that again?
Yes.
Okay, so I'm gonna, so I'm gonna open a new tab, right?
Yes.
And then I'm gonna search for Sickle in Africa GitHub, like that, you see in the Google search. So I'm doing a Google search for Sickle in Africa GitHub, do you see?
Sickle in Africa, good.
Yeah, GitHub.
Okay.
Got it? And then that second link, you see the one that says Sickle in Africa -GitHub there, that second link.
Okay, yes.
You got that one?
Yes.
Cool. All right, see, are you on the page that I'm on now?
Yeah.
Cool. So scroll down and then the top one, see this top one that says SIA database workshop, that blue link there. Most of you will probably see a white background instead of a black one, but it's the same website.
Okay.
Okay, so I'm going to click there. You see?
Yes.
You got it? And then this green one, you see this green one? I think it's green in your. Just to remind you, the background for mine is black, but for you guys, it should be white.
Yes.
But the code button's still green. Okay. So are you going to copy that link there? You see? So this copy button there. You got it?
Yes.
Cool. All right. Okay. So then we go back to the RStudio Cloud tab.
Okay. Mm-hmm.
There now. And then top right-hand side, you see this new project button there.
Yeah. Yes.
Click that one. Scroll down to new project from Git repository.
Yes.
Got it? Right. And then paste your link in there.
Okay. Thank
Got
you.
it?
Yes.
And then, cool. And then press OK. And now we've got to wait for it to load. So what it should do is pull the code from GitHub into this online notebook. So you don't have to install anything, but this will give you R, access to R. So we'll just wait for that to load. I'm sure it's loading on everyone's computer now. And then we can start doing some analysis stuff. Oh, okay. Just while that's loading, there's a lot of stuff on this GitHub page. So in particular, the code that we're going to use, if you click on this folder there, and then you click on this file, dataquality.r, this is the code that we've just downloaded. And this is the code that's like an example tutorial script for cleaning a data set in R. I think it's important to mention that in Red, you should be doing most of your cleaning in REDCap, i.e. most of the cleaning should be preventative, right? Rather than fixing bad data, you should be setting it up so that people can only enter good data. That's it in an ideal world. But sometimes you don't want to be too restrictive, otherwise you lose important data. And also sometimes you really can't put in checks for things like outliers. So if someone puts an age in of 154 or maybe even 271, it's very hard for you to stop these kind of outlying data points in REDCap. So we sort of want to focus on those kind of data mistakes in R. That's after the data's been collected. Is everybody here now? Can I just check that everyone is here? If I go to RStudio Cloud, this is what I'm seeing on my screen. Kutal is there, perfect. Okay, cool.
Not yet. It's still, yeah, now it's coming.
It's coming now.
Yeah.
Perfect. Okay. We got it.
I don't know.
Oh,
For others, for me, it's coming now.
okay. So this is a cloud computing system. So the internet it's using is the internet at the cloud site, which is wherever RStudio Cloud is based. So it shouldn't be using your own internet to run things.
Okay.
Okay, are we all there? Evans is there. Okay, cool. So what I'm going to do now, I'm going to go down to the bottom right-hand side and click on this folder that says Data Quality Assurance in R. Can you see it? There it is. There it is. And then in there, there's a file called dataquality.r. Do you see it? I'm going to click on that one. And then you can see that's opened my code in this top left-hand box, right? I'm not sure if you can see that. So there's all this code stuff. It's long, quite long. But you might be able to see that this code is exactly the same as the code that's on the GitHub thing. So we've just pulled that code in, but now we can use it. All right, cool. I think enough of us are there. So a little bit of an introduction. This is an RStudio session. It will look the same on your desktop if you install it, except that it won't have any of these browser stuff at the top. But it will look the same on your computer. So you'll have these 4 squares. And then within those 4 squares, all your analysis can happen. And the thing that's important really to me, my favorite bits are the scripting bit here on the top left box, and then the console here, the bottom left box. And most of the things you do it can be done with those 2 things. Everything else you can ignore for now. So the first thing we want to do is get some data. I have chosen to use, there's an online resource for data. It's called the UCI Machine Learning Databases website. It's not important, I'll tell you a bit about that later. But what we're going to do is, first of all, grab the data, which can be done by running this first command here. So I need you all to highlight this first command, which is from line 6 to 8. There you go. And then to run it, you're going to hold down Control on your laptop and press Enter. And what you should be able to see is it copies that command down into the console below and runs it. Can you see that? Now there's all this blue down there. Oh, and Arthemon's pointed out that I can press Control Enter, or I can press this little run button at the top. I can also press that. Okay, everyone's saying yes. I think everyone's here. All right. So we want to see if the data is actually here. There are a few ways you can do that. They all help depending on what kind of computer experience you have. The first way is if you go to this top right-hand box, do you see? There is this block, this heart disease data variable there. I'm going to double click on that. And it's opened this spreadsheet. Can you see on the right-hand side? And that's all your data that you've just imported. Another way you can see it, this is my favorite way you can see it, is by typing the following command on line 11. So you see here, line 11 of the dataset, I'm going to highlight it, press Control Enter, and then that gives me the top 6 lines of my dataset. So I can have a peek at what it looks like without seeing the whole thing. How's everybody doing so far? Are we good? Good, good, good. Evans is good. Kutala's good. Okay, let's move forward. So that's kind of interesting because you can see the numbers and you can see the columns, but it doesn't tell you too much about the structure of the data set as a whole. A command that's better for that is this one str command on line 12 of your file. So let's highlight that one, run it. And now this is a bit more interesting. This is telling me that I have 303 observations of 14 variables, and my variable names are given on the first column down here. And then the values are given on the right-hand side. And in the middle, this is very important, is the type of variable that R has assumed that it is. Okay, this is really, really important for analysis. So the top ones are labeled as number, and then variable 12 and 13 are labeled as character, which shorthand is CHR. Now it's kind of weird because if you look at the data, you should see that column 12 is numbers. So it's a little bit surprising that they have been given a character type designation. We need to investigate this. It's going to be a problem for analysis downstream. This is sort of indicating that it's not so good to have an automated pipeline. And what you really need to be doing is having a look at things yourself. Okay, we're all good. Okay, so yeah. The first thing I want to do, because V1 to V12 is not very informative for column names, so we're going to rename the columns. The best way to do that is to go to the data dictionary, which is here. So I'm going to copy that link, go to the data dictionary. I realize I've got to speed up a bit because we're running out of time. This is where I've taken the data from. So the data actually came from here. I think it's processed Cleveland data, but the data dictionary is here. So if you scroll down, you can see what the column names are. There's column 1, and then what the columns represent. Do you see? If I scroll down further, there's a more detailed description of what they mean. Yeah, so I've done that already in the code. I've gone to the data dictionary and I have got a map between the column name and the column number. So what I'm going to do now is copy lines. Let's highlight lines 34 to 20. You see? Highlight line 34 to 20, and then I'm going to run it. And this command has just updated the column names of my data set. So if I have a look, oh, sorry, no. If I press down in the console below, I type head, open brackets, heart disease data, and run it. Now my data set looks nice. There's age, sex, and then all these other things. I don't exactly know what they are. If I open up my data set as a spreadsheet, these have also been updated, so that's nice. Okay, so we're going to keep going a bit further, a bit fast because we're running out of time. The next thing I want to do is look for missing values. Now, missing values usually in R are coded as NA. The problem is they're not always coded like that in the data set source. And in this case, I can show you, for example, are there, let's see, heart disease. I'm going to type in my console below, $ age. This is all the values of age in the data set. There they are. And there's no missing values, so that's fine. But if I look at, for example, the CA column, then I see no NAs, but you might be able to see these exclamation, these question marks there. So what we found is that the data set here actually codes missing values with question marks, which is kind of weird, but that can happen. So the next line in the code is this one here, which I've highlighted, line 41. So we're going to run that one, and that is going to replace question marks with NAs. So I've run it, see I've run it, and now if I type it again, I have a look again, you see where there were once question marks, there are now NA signs, do you see? Let me just pause. Is everyone with me? Is everyone understanding? Making sense? I'm going to go a bit, all good. I'm going to go a bit faster now because we're running out of time. But if I show you again, the thal column, you can see the same. So in the thal column, there's another exclamation, there's another question mark. So this line 42 is going to fix that problem. So I'm going to run it. And then if I view it again in the console, again, I've fixed it to it's now NA. This is important because R interprets NA as missing value. Anything else is going to give it problems. Also note, NA and NA in quotes are not the same thing in R. Very important. Okay, so next thing, the problem with this one is that all these values are in quotes, even though they seem to be numbers. So this is kind of weird. What we want to do is change them into numbers. And we want to also have a look at some of the other columns. For example, let's see, sex. This is kind of weird because if I look at the structure of the data set, oh no, let's use data. If I scroll up, sex is classed as a number, but the values are only 0 and 1, and it seems impossible that sex could ever be a number. In fact, what's going on here is 1 corresponds to male and 0 corresponds to female. So we need to change that. So line 46 of our thing will change that. We run it. And now let's have a look at it again. The structure, if you go to sex, it says now factor levels FM. So now if I peek at my data set, oh, I'm not speaking, my microphone is not good. Can you all hear me? Okay. You can hear me? Okay. So I'll try and speak a bit louder. But now you see sex is encoded as M and F, and they're factors, not numbers, which is good for analysis downstream. I'm going to do the same for all the other variables. I've already done this in the code, so I'm just going to highlight this block. There we go. And then I'm going to run it. Oh, no, wait, sorry. Okay, so we've got an issue there. So I'll just, ooh, okay, let me try. I've got an error, which is not good. Control and enter. Okay, we'll just run these top ones. I'll fix that error later. Okay, I'm running it. All right, let's have a look at the data set. There we go. And now it's looking a little bit better. Okay, so now what do you want to do? We want to look for, maybe we'll look for outliers next. So one of the best ways to look for outliers in R is to just make a box plot. So the way the box plots in R work is that they calculate the median or the quantiles, and then they calculate or they estimate any values that seem to be outliers. So line 62 will draw a box plot for the age variable. So let's have a look. I'm going to run it. And there's my box plot in the side window. And you can see that it looks like a simple box plot where the median is drawn and the upper and lower quartiles are also drawn. And I can't see any outliers from this plot. So it seems like there are no outliers for the age value. If I instead, however, draw a box plot for this variable here, thalak, I can't tell you exactly what that is. You can see a little dot below the box plot. Do you see it? R has classed that one as an outlier. So this variable seems to be outlying the distribution. So this record could be a bit of a weird one. There are other ones where there are more prominent outliers. So let's run line 64. You can see there's quite a few outliers at the top there. So R has flagged these top points as ones that are cause for concern. We don't know right away that these are outliers. We have to go into the data set and check a bit more. And then the same for the call variable. I'm going to run line 65. You should see the same thing. Okay, again, this one in particular looks pretty bad at the top. I'm running way over time, so I'm going to try and do this quickly. Another thing we want to do is check the normality of our variables. That's good for tests downstream. So I'm going to run this hist command and draw a histogram of the data. And it looks pretty normal. It's pretty symmetric. It's got tails. It's got a middle bump. It looks okay. I could even draw a QQ plot, which is gone by running lines 69 and 70 together. And you can see that the data points lie pretty close to this line, which tells us that our age is pretty much normal. In contrast, if I choose this variable old peak, I'm going to draw a histogram of it, and it doesn't look very normal at all. In fact, if I draw a QQ plot of this one, you can see that it's definitely not normal. So something weird's going on there. There's more commands in this data set. You can do them all. I'm going to go quickly through them all now. I can draw a table, for example, of the sex values. What else can I do? I can create a new column, and I can do a chi-square test. Oh, okay. All right, I think we should stop here. We're getting to the end of the script. I'm going to stop there now, but if you take this in your own time and you run these steps and you understand what they're doing while looking at this code book, then you might be able to get a better understanding of what I've been racing through just now. But I'll stop now and I'll take questions.
Thank you, Jack, for that demonstration. See in the chat box that is hand raised from Passion's Corner. Do you have any question to Jack?
No, I don't. I was giving a thumbs up that we were all good when she
Okay,
asked.
great.
Yeah.
Great.
I'm not so, this is Saro from Mali. I'm not so familiar with R, but is this code written by yourself, or this is in one library available for everybody?
Oh, this is the code. I wrote this myself.
Okay.
But it is available for everyone on that GitHub account, so you can just download it and use it.
Okay.
But yeah, it's available. Yeah, I mean there are lots of code. There are lots of examples online that you can copy and paste from.
Okay, thank you.
Okay, I see a comment from Ruben. Nice job, Jack. You have made a good illustrations for the concepts of R. I've also seen on the chat box that from Isaac Yano. He said that, can you show graphically missing values in a variable?
Yeah, and that's a good question. I'm not sure. I think you can do it in a table. It depends on what the data type is, I think. Yeah, I mean, the simplest way I think is to use the summary function. So if you can see my screen still, I'm going to type summary and then put the data in there. And then there's a whole bunch of stuff is coming out. It should give me missing values. I can't remember where it does it. Okay, it's a good question. I'll have to get back to you on that one. I'm not sure how you'd visualize missing values, but that would be an interesting thing to do for sure. I'll have to get back to you, Isaac. I'm sorry, I'm not quite sure. Pardon? Oh. I'm getting a recommendation from Kevin that you encode the missing values in some type of variable and then plot them that way. That might be nice. Everything's possible in R, you just have to find the hack. But yeah, Kevin, that's a good solution, yeah. I'm also being recommended by Arthemon that I mentioned tidyverse. I didn't explain it because you have to install it and it can take a long time to install, but once you get around to it, it's really, really good. So tidyverse, I would really, really recommend it once you start getting the grips to the beginnings of R. Are there any? Hello?
Yes, I don't see any question from, okay, from Kevin. So if you are using GitHub user and use SSH keys for authentication, you might have noticed that copying the R project from the SickleInAfrica GitHub page to the R Studio was not allowed. Make sure to switch to HTTPS before copying. So I think that is an announcement, or it's just a point to note when we are taking data for our project from GitHub. Okay. Can we give Jack more of time, or we should go to discussions for all the sessions that have been passed? Jack,
Hi, Daniel. Yeah.
do you need any of the time maybe for demonstrations, or you want us to end here?
Yeah, I mean, I can try some more stuff. There was one thing I didn't get around to doing was a demonstration of a chi-square test. Do people want to know how that would work? It's very quick.
Yes, please.
Okay. So it's in the data set. Okay, so I'll do a quick chi-square test first before I finish. Okay, so the data set is here, right? I've got it loaded in my console, and everything, you can see all the variables and stuff. Where are they now? And then what I've done is I've created for myself a new column. So let me explain a little bit more about these columns. They're all a little bit opaque because I've just pulled this data set from some online repository. Sex is obviously quite self-explanatory. Age is also explanatory. This num column on the end here is perhaps not. What num means is it's the number of events observed by doctors that give evidence to the fact that that person has got some kind of heart disease condition. So you can see if it's 0, it means that person has effectively no evidence of any heart disease. If it's 1, they have some evidence, 2, that there's more evidence, 3, and so on. It's what we can do. It's quite helpful to dichotomize this variable. I make it true or false, and we can say if 0, that person has got no heart disease. If greater than 0, that person has got heart disease. So you can see in one of the lines down here, I think it's this one. Yes, 990. I've created a new column, and the details of that are really useful if you want to pick this command apart later on. But what it does is it says, right, if num is 0, then say no heart disease. If num is greater than 0, then say yes, heart disease is present. So now we've got a binary outcome variable, right? And we want to know if some of these, the predictor columns, have anything to do with this heart disease column. A simple test you might want to do to begin with is to say, right, does the sex of my patient have anything to do with their risk of getting heart disease? So let's do that chi-square test now. The null hypothesis would be that there is no difference between heart disease risk for males and for females in my cohort. That would be my null hypothesis. So what I want to do is quickly draw a table, which is done by line 97, to have a look. Oh gosh, Control Enter. And now, wait, oh, I need to, something's gone a little bit wrong. So I think I want to, I'm going to start again. So let's clean my workspace and start again. All right. Let's start again. Control Enter. There we go. All right. So something got a bit mixed up. If anything gets a bit mixed up, if you find you've deleted something that you shouldn't have, what you can do is press, you see this like little sweeping thing, this broom in the corner. If you press that, it removes all the objects from your workspace and it allows you to start again, which is fine because all your objects are really in this code. So as long as my code is the same, I can always remove a variable and then bring it back. Okay, so let's go down. So what I did was I made this new variable. We've seen that. I'm gonna look at my data set. Again, here we are. There's the heart disease column and the num column, right? So I'll kind of
Jack?
gone a bit off tangent there. Yeah.
I'm sorry,
hi, Mary.
for me, I can see your chat box. I can see a gray box. That's your chat box, but it covers the image to the
Oh.
right. So yeah, if you can move it out of the way, please. Thanks, man.
Sorry about that.
Yeah, so now it's on top of the graph again.
Okay, so I can see the chat
Yeah.
on Arthemon's computer. Okay, cool. So
Sure.
to go back to the beginning, thanks, Mario. I've got this column here, heart disease, which is yes, if someone has heart disease, and no, if they don't. And what I want to know is, does the sex of the patient have any influence on the risk of them getting heart disease? That's my chi-square test that I'm going to construct. So the null hypothesis is that no, there is no difference between heart disease risk for males and for females in my cohort. So the first thing I'm going to do is draw a table so I can visualize that. And there's my table. Do you see it at the bottom? For females and males, the no category is 72 and 92, and the yes category is 25 and 114. That's my 2x2 table, okay? Everything there is enough to do a chi-square test, and the chi-square test is done with the second line, line 98. So I'm going to run it, and then the output of the R function, this function is called chi-square test. The output is shown in this console below. Can you see that console output there? The important thing is that the data that I'm using is the sex column and the heart disease column. Both these columns are binary. They have only 2 values. The chi-square value is 22.045, 0.43. There's 1 degree of freedom, which is what we expect from this kind of test. And importantly, the p-value is roughly 2 × 10⁻⁶. So based on that, we can safely reject the null hypothesis that there is no difference between heart disease risk for males and females in this cohort. Said another way, if you are male or female, that will affect your risk of heart disease. So we need to do a little bit more digging to find out in which direction that works. But the more important thing is we've rejected the null. So this one line here, 98, is a blueprint for how you would do a chi-square test in R. Okay, so if you wanted to change the column, which I can do now, which I won't do now in case it breaks. But if you wanted to change the column, I would just change that in there. And then I want to probably keep that because that's my outcome. And then I'll just run the command again and I get the same test for a different set of columns or variables. Okay, I'm going to stop there because I just have a tendency to run.